is Garrett Edmondson with Azure Ada, and in this presentation I will provide an overview on Cardano, focusing on those key components which makes this a unique blockchain protocol. The first couple of sections will focus primarily on Cardano's relationship with academic research and peer review, also how that relates to security and making this the most secure blockchain. The next couple of sections, I will dig into the protocol itself by discussing the consensus algorithm and its ability to promote long-term sustainability within the ecosystem. The last couple of sections will focus on government, particularly community participation and how that can be used to enhance the protocol into the future, and also programmability, the ability for this blockchain to integrate with applications. The academic research and peer review process form the center of the Cardano protocol, making it unique amongst other blockchains. One of the principal organizations responsible for the majority of the research to date is an organization called IOHK, and they have produced thus far 95 white papers, several of which have been submitted to various academic conferences. For example, the paper entitled Ouroboros Hydra, which is the latest version of the consensus algorithm, which I will explain later, has been submitted to the appropriate financial cryptography conference. Given the academic and peer review process, there are several unique components to the protocol's security, in that it is possible to verify that the code that is written to produce the protocol does in fact match the academic paper or papers. One way to do this that is available to many other such blockchains is to look at the code directly. This is because Cardano is of course open source. However, uniquely, it is also provably secure through the use of formal methods. These are mathematically verified to prove that the code in fact matches the academic paper. This is possible because Cardano is written in a functional programming language called Haskell, which has the ability to be able to be verified through the use of this formal methods process. At the heart of the Cardano protocol is the consensus algorithm. Cardano's consensus algorithm is called Ouroboros. Because Cardano is decentralized, meaning there is no central authority making or governing the rules and operations that occur on the blockchain itself, all these have to be written in computer code, as discussed previously. You can think of the consensus algorithm as a system of rules and parameters that govern the blockchain itself. For example, the acceptance or rejection of new transactions on the blockchain. For Cardano also, there is a rewards and incentive structure that reinforces network participation. A good example of this is the stake pool delegation process, which awards both ADA holders, the delegators, and the stake pool operators for participating in the network. One of the key aspects of Cardano's sustainability is its efficiency. Cardano is a proof-of-stake protocol, which means that it is inherently much less computationally intensive to secure than a typical proof-of-work protocol, such as Bitcoin. An example of this is that you can run the entire Cardano protocol on a relatively simple, low-powered device, such as a Raspberry Pi, pictured here. These Raspberry Pis are used for various pursuits and other hobbies, and is a demonstration of the ability of Cardano to be run with minimal resources. Another important aspect of Cardano is its governance policies. One of the most unique and probably most important is one called Catalyst. This is a program that involves the improvement of Cardano through the community. This has many features to it as well, but most importantly, it is a decentralized treasury with funds that accepts proposals and then has a community-based voting system that the community gets to vote on these proposals in order for them to receive funds. One example of this is the latest fund as of this recording is Fund 4, and it has available in it about $1 million. Perhaps the most important and valuable part of Cardano is its ability to interact with the rest of the world. This is possible because Cardano and its blockchain are fundamentally open to programmability. One of the languages that is native to this is Plutus. Plutus can be thought of as a subset of the Haskell language specialized for writing programs on the blockchain. Cardano's blockchain is unique in that it has what is called an extended UTXO model that intrinsically supports the use of programs within it. These programs are sometimes referred to as smart contracts. Smart contracts are simply applications that interact with the blockchain by either importing data from the blockchain or exporting data to the blockchain. One example of this is native tokens. With native tokens capability, the Cardano blockchain can interact with other blockchain technologies such as Bitcoin and Ethereum, and also with real-world systems such as those providing services and goods. Another important aspect of this ability is also the ability to tie identity to the blockchain in a decentralized manner to allow for authentication and authorization